Hello everyone, welcome back to our channel. As you might already know from the title, I'm Taskin, and in my previous video we covered chapter 1 of chemistry IGCSE Edexcel. Today we will be covering chapter 2, which is elements, compounds and mixtures. First off, let's start with what do we mean by elements. Elements are substances that can't be split into anything simpler even by chemical means. For example, nitrogen, oxygen, iodine, and chlorine, they all exist as diatomic molecules. It is very hard to separate them, and even if we do separate them, it takes a lot of energy and it's very tough to do so. Next up, we have compounds. Compounds is basically when two or more elements or atoms combined chemically. They always combine in fixed proportions. Some of the examples are water, methane, ammonia, etc. Next up, we have mixtures. In a mixture, the various substances are mixed together and no chemical reaction occurs. Mixtures can be made from elements and or compounds. The various components can be in any proportions, for example, air, sea, etc. Next up, we have some differences. This will help you to differentiate between the two commonly mistaken things, mixtures and compounds. First up, for mixtures, we have molecules can be mixed in any proportion. However, in compounds, molecules are mixed in fixed proportions. Number 2, in mixtures, each element keeps their own properties. However, in compounds, elements entirely change their chemical reactions. Number 3, mixtures can be separated by physical means, and for compounds, they can only be separated by chemical means. Let's have a look at melting point and boiling point. Melting point, the temperature where a solid changes its shape to a liquid. A famous example is the melting point of water is 0 degrees Celsius. Boiling point, the temperature where a liquid starts to boil and turns gaseous. For example, the boiling point of water is 100 degrees Celsius. Another thing you should take note of is that the presence of impurities in substances lowers their melting point, and however, it raises the boiling point. Now coming to separation of mixtures. There are 6 methods in total, and they are used to separate mixtures, various types of mixtures. First up, we will be having filtration. This method is used to separate a solid and a liquid. The method is very simple. You pour the solution in the funnel and it seeps through the filter paper while separating the solute and the solvent. The solvent falls into the beaker. Substances left in the filter paper is called residue, while substances that pours down into the beaker is called filtrate. Next up, we have crystallization. This method is used to separate a solute from a solution. The procedure follows. The solution is heated in an evaporating basin to boil off some of the water until an almost saturated solution is formed. This can be seen by dipping a glass rod into the solution and seeing if crystals form quickly on the surface when removed. The Bunsen burner is then turned off and the crystals are allowed to form as more water evaporates and the solution cools. The crystals are now removed via filtration. Next up, we have simple distillation. Simple distillation is a method used to separate the components of a solution. This is a very simple method. As you can see from the diagram, when heat is applied to the NaCl solution, the water will evaporate and down the condenser to create pure water. Next up, we have fractional distillation. Fractional distillation is where separation of mixture of liquids occur, for example, ethanol and water. As they have different boiling points, the individual liquids separate individually. For example, boiling point of ethanol is 78 degrees Celsius, so it evaporates before water whose boiling point is 100 degrees Celsius. Next up, we have paper chromatography. Paper chromatography is a method used to separate various mixtures. However, in IGCSE, we only know about the separation of ink colors or dyes. Now, what you need to know is that the baseline must always be in pencil. This is because if you use ink, it may also dissolve in the solvent and hamper with the results. Another thing that you need to know here is calculating the RF value. The RF formula is pretty simple. It's distance moved by the spot divided by distance moved by the solvent front. Well, that was all today we had. See you next time.